Hi guys! In previous videos we've shown how to create a ragdoll effect in Unity. Today we're going to look at how we can reverse this and have the character stand back up again. We'll start with a quick recap of how we set this scene up. If you want more detail, then take a look at our Ragdoll series. Alternatively, you can download this project by supporting us on Patreon. All the relevant links can be found in the description. Okay, so we have a zombie in the scene that has colliders representing individual limbs. There are character joint components to join the limbs together, and we have rigid body components so that the limbs react to gravity and physics. When the zombie's walking, the rigid body components are set to is kinematic, which stops forces acting on them. When we want to trigger the ragdoll effect, we turn off the animator and character controller, and we set is kinematic to false on all the rigid bodies. This then allows the limbs to react to forces and collisions, and the zombie falls to the ground. So how are we going to reverse this? The obvious thing to do would be to do the exact opposite of what we did to trigger the ragdoll. So we'll set the rigid bodies back to is kinematic, and we'll turn the animator and character controller back on. Let's go to the zombie script to do this. The first thing we'll do is add a private float field for the time it will take for the zombie to wake up. Then we'll go to the method where the ragdoll's triggered. Let's add a line in here to set the time to wake up. We'll set this as a random value between 5 and 10 seconds. If we then go to the update method, we can see we have a very basic state machine. When the zombie is in the walking state, we execute the walking behaviour. And when it's in the ragdoll state, we execute the ragdoll behaviour. At the moment, the ragdoll behaviour method is empty. Let's add some code in here to reverse the ragdoll after the time to wake up has elapsed. We'll start by subtracting time.delta time from the time to wake up value. Then we'll check if the time has reached 0. If it has, we'll set the state back to walking. Then we'll call the disable ragdoll method. This method sets all the rigid bodies back to is kinematic and enables the animator and character controller. Let's save this and give it a try. We'll click on the zombie to trigger the ragdoll. Then we'll wait for it to wake up. We see that the zombie just snaps back to exactly where it was before, as though nothing ever happened. So we have reversed the ragdoll and got the zombie walking again, but we're still a long way from making it look good. First of all, let's look at why the zombie's position snaps straight back. We'll trigger the ragdoll again. Then we'll pause the game and switch to the scene view. If we click on the zombie in the hierarchy, we can see all the colliders of the ragdoll. But over here we can see the collider for the character controller. This is the position the zombie was at when the ragdoll was triggered. When we trigger the ragdoll, the limbs all move relative to this position, but the position of the parent zombie object doesn't actually change at all. So when we turn the animator back on, the animation starts back from this position. We want the zombie to start walking from where it landed, so we're going to realign the position of the zombie to the position of the hips bone. Let's stop the game and switch back to the script to do this. First of all, we need a field to hold the transform of the hips bone. Then, in the awake method, we'll use the getBoneTransform method of the animator and specify that we want the hips bone. Next, we'll create a new private method called AlignPosition to Hips. The first thing we'll do in here is take a copy of the current position of the hips. Then we'll set the position of the zombie to the position of the hips. Now the zombie will be in the right place, but by changing its position, all the child objects will also have moved. That's why we stored the original position of the hips, as we can now set it back to this position. This will change the position of the hips local to the parent zombie object, so that it's in the same world position as before. If you want more detail on world and local positioning, then take a look at our dedicated video on this. One other thing we need to do in here is make sure the zombie is on the ground when it starts walking again. To do this, we'll fire a ray down from the hips and get the Y position of whatever it hits. We'll use physics raycast. We'll pass in the position and we'll fire the ray down. We'll get the hit info as an out parameter. If there's a hit, we'll change the position. We'll use the existing values of the X and Z position, but we'll use the Y position of the hit point. Now we just need to call this new method from the Ragdoll behavior method. Okay, let's save the script and switch back to Unity to try this out. We'll click on the zombie to trigger the Ragdoll. We'll wait for it to wake back up again. Now the zombie starts walking from where it landed. This is better, but still not great. The next stage is to add an animation of the zombie standing up. Let's stop the game and head over to mixamo.com to get an animation. First of all, we'll go to the Characters tab and make sure we select the Romero zombie character we've been using. Next, we'll go to the Animations tab and search for Stand Up. We'll select this one with the character starting off on their back. If we watch the animation, we can see the arm of the zombie clips through its leg. To fix this, we'll increase the character arm space. That looks better. Now we'll download the animation. We'll select FBX for Unity and without skin. Then we'll save it to the Animations folder of the project. Let's switch back to Unity and find the new animation in the Assets panel. We just need to change some of the settings on the animation before we can use it. We'll select the Rig tab and change the animation type to Humanoid. For the avatar definition, we'll select Copy from Other Avatar and select the avatar of the zombie. Then we'll click Apply. Next, we'll go to the Animation tab. As we don't want the animation to affect the position or rotation of the character, we'll bake all the transforms into the pose. We'll also set all the based upon values to original to use the original values in the animation. If any of this seems unfamiliar, then take a look at our video on root motion, where this is covered in more detail. We'll click Apply to save the changes. Now we can add the animation to the zombie. We'll open the animator for the zombie. Then we'll drag the stand-up animation into the animator window. We want the stand-up animation to transition to the walking animation once it's finished. To do this, we'll right-click on the stand-up state and select Make Transition. Then we'll click the walk state to create the transition. If we click on the transition, we can see a preview of how it'll look. At the moment, there's too much of a delay between the zombie standing and it starting to walk. We'll reduce the exit time to 0.7 so that it transitions to walking sooner. We'll also increase the transition duration to 0.5. Let's see how this will look. Okay, that looks better. Next, we need to go back to the script to trigger this animation. At the moment, we have a walking state and a ragdoll state for the zombie. Let's add in another state called Standing Up. We'll create a new method called Standing Up Behavior to handle the behavior when in this state. Then in the update method, we'll add the new state to the switch statement and we'll call the new behavior. Now in the Ragdoll behavior method, rather than going straight to the walking state, we'll switch to the Standing Up state instead. We want to play the standing up animation and when it's finished switch back to walking. To do this, we need to know the name of the stand up animation state. We'll add a serializable string field to hold the name of the state. Then we'll go to the Ragdoll behavior. In here, we'll start the standing up animation using the animator play method. Then we'll go to the standing up behaviour method. We want to wait until the stand-up animation has finished before switching to the walking state. To do this, we'll check if the current animation state is the stand-up state. We'll get the current state info from the animator. We'll pass in 0 as the layer index. Then we'll use the isName method to check if the state name is the stand-up state name. We'll check if this is equal to false. If it is, the animation must have finished, so we'll set the current state to walking. OK, let's save this and switch back to Unity to try it out. We'll select the zombie in the hierarchy and set the stand-up state name to stand up. This matches the name of the state in the animator. Let's press play to try this out. Now the standing up animation plays before the zombie walks again. This is a step in the right direction, but it's still quite jarring. The next step is to add a smooth transition between the ragdoll and the start position of the stand-up animation. Let's stop the game and switch back to the script to see how we can do this. What we're going to do is get the transform of all the bones from the first frame of the stand-up animation. Then we'll get the transform of the bones when the zombie's in the ragdoll state. We can then smoothly transition between the two. We'll start by creating a private class to hold the transform information of each bone. We'll add a public vector3 property to hold the position of the bone. And we'll add a quaternion property to hold the rotation. Then we'll add a field to hold all the bone transforms of the stand-up animation. We'll add another to hold the bone transforms of the ragdoll. We'll also need an array of type transform to hold the actual transform of each bone. Now we need to populate these arrays. In the awake method, we can populate the bones array by getting all the child transform components from the hips bone. This will get all the bone transforms, including the transform of the hips. Now we have all the bones, we'll initialize the other two arrays, using the number of bones to set the size. Then we'll create a for loop to loop through the number of bones. In here, we'll create a new bone transform object for each array and assign it to the index position. This will initialize each of the arrays so there's a bone transform object for each bone. Next, we need to be able to populate these with a snapshot of the actual bone transforms. We'll create a new private method to do this. We'll call this populate bone transforms, and we'll pass in the array we want to populate. In here, we'll create a for loop to loop through all the bones. Then we'll set the position of the bone transform to the local position of the bone. We need to use the local position, as we want to ignore the world position of the zombie, and just get the position of the bone local to the zombie. We'll then do the same for the rotation. So this method will take a snapshot of the current position and rotation of the bones, and store it in the array passed in as a parameter. We now need to use this method to populate the two arrays. We'll start with the ragdoll bones, as this is the easiest. Let's go to the ragdoll behaviour method. In here, we'll populate the ragdoll bone transforms before the zombie starts to stand up. This will take a snapshot of the bone transforms while the zombie is in a heap on the floor. Now we need to get the bone transforms for the first frame of the stand-up animation. We can do this by sampling the animation. For this, we'll need to know the name of the animation clip. The name of the animation clip may differ from the name of the animator state, so we'll add a new serializable field for this. Then we'll create a new private method to populate the bone transforms for the start of an animation. We'll take the clip name as a parameter. We'll also take the array of bone transforms to populate. Next, we need to get the animation clip that matches the name. The animator object has a runtime animator controller property, and this has a collection of all the animation clips. We'll loop through all the clips. Then we'll check if the name of the animation clip matches the clip name we're looking for. If it does, we'll sample the clip, passing in the game object for the zombie. We'll set the time to 0 to sample the first frame. This will now set the bones of the zombie to the first frame of the animation. Next, we'll call the method to populate the array and create the snapshot. Then we can break out of the loop. There is an unwanted side effect of sampling an animation that we need to cater for. The transform of the zombie will be reset when the animation is sampled, so we need to set it back afterwards. We'll store the position and rotation before the sampling. Then we'll set it back to these values after the sampling. That's all we need for this method. We'll go to the awake method and call this. We'll pass in the stand-up animation clip name and the array to populate. Now we have both arrays populated. The next thing to do is transition from one to the other to reset the bones. We'll add a new state for the zombie called Resetting Bones. Then we'll add a serializable field for the amount of time it will take to reset the bones. We'll also add a private field to record the amount of elapsed time in the bone reset process. Next, we'll add a new method for the reset bones state behavior. Then, in the update method, we'll add the new state into the switch statement. Let's go back to the method to fill in the detail. We're going to use lerp to transition from the Ragdoll bone transforms to the stand-up animation bone transforms. First of all, we'll increase the elapsed time by time.delta time. Then we'll calculate the elapsed percentage by dividing the elapsed time by the total time. Next, we'll create a for loop to loop through all the bones. Then, for each bone, we'll set the local position. We'll use vector3 lerp to transition from the Ragdoll bone position to the animation bone position. We'll use the elapsed percentage as the interpolation value. Then we'll do the same for the local rotation using quaternion lerp. Once the transition is complete, the zombie should be ready to seamlessly go into the stand-up animation. We'll check if the elapsed percentage is greater or equal to 1. If it is, we want to start the stand-up animation. We already did this in the Ragdoll behavior method, so we'll go and grab the code from there. We'll cut these lines, and we'll paste them into the resetting bones behavior. Then, back in the Ragdoll behavior method, we'll set the state to resetting bones. And we also need to set the elapsed reset bones time back to 0. OK, let's save the script and switch back to Unity to see how this looks. We'll set the stand up clip name to stand up. And we'll set the time to reset bones to 0.5 seconds. Let's press play to try it out. The bones now transition smoothly, but the zombie noticeably slides along the ground. Let's stop the game and switch back to the script to have a look at how we can improve this. If we look at the Ragdoll behaviour method, one of the first things we did was to align the position to the hips. We didn't align the rotation though. This means that when the bones are being reset, the hips need to rotate, which causes some of the sliding issues. Let's create a new method to fix this. In here, we'll first of all take a copy of the original position and rotation of the hips. This is so that we can set the hips back to these values once we've aligned the zombie. Then we'll get the desired forward direction. We want this to be the down direction of the hips, pointing towards the zombie's feet. To get this, we'll use the up direction of the hips and multiply it by -1. We'll then remove the Y component of the direction, as we want the zombie to face straight forwards. We need to normalise the vector to make it a direction vector with a magnitude of 1. Next, we'll create a rotation to rotate the current forward direction of the zombie to the desired direction. We'll use the quaternion from-to rotation method to do this. Then we'll multiply the current rotation by this value. This will rotate the zombie to face the direction we want, but by changing the rotation, the child hips bone will also have rotated. We don't want this, so we'll set it back to the original rotation and position that we stored at the beginning of the method. This will update the local transform of the bone relative to the zombie, so that it appears in the same place in the world as before. Now we just need to call this method from the Ragdoll behaviour method. We'll align the rotation before the position, as next we're going to look at an improvement to the position alignment that needs the rotation to be correct. At the moment, we're aligning the position to the position of the hips. We're not taking into account the local position the hips bone has in the stand-up animation. That's why the zombie has to slide into the correct position. Let's calculate the offset we need by getting the position of the hips from the first element of the stand-up bone transforms array. We'll remove the Y component of the offset, as we don't want to move the zombie up or down. Before we can apply this offset, we need to rotate it so that it's in the forward direction of the zombie. To do this, we'll multiply it by the rotation. Then we'll subtract this offset from the position. Let's save this and see how it looks. This looks much better. The resetting of the bones is much less noticeable, but we can still do one more simple thing to improve it. At the moment, the stand-up animation starts with the zombie flat on the ground. This means the bones have to transition to completely flat before starting to stand up again. If we trim the start of the animation so that it starts once the zombie is already getting up, then it will look much more natural. Let's stop the game and select the animation in the Assets panel. We'll set the start frame to 70. We can see in the preview that the zombie is already starting to sit up now. Let's click Apply and give this a try. Now the movement looks much more natural. So far we've been testing with the zombie landing on its back. Let's shoot it in the leg to see what it looks like when it's face down. It has to completely flip over, which doesn't look that great. We'll look at how to fix this in a future video, but have a go yourself for now and let us know in the comments how you get on. Okay, that covers everything for this video. Hope you found it useful. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Please leave any questions or feedback in the comments and subscribe and click the bell icon so you don't miss the next one. Thanks guys!